Welcome everyone! In this explainer, we're going to unpack a really powerful statistical tool, the chi-square test, and we're going to do it by looking at one of the most famous events in modern history. Alright, let's jump right in with a really powerful question. This might sound like just a piece of history, but it's a question we can actually answer, for real, using data, in a little bit of statistical detective work. Here's how we're going to tackle this. We'll look at the survival question, introduce our statistical detective, see how it compares reality to random chance, use it on the Titanic's data, and then figure out the final takeaway.
Okay, first things first. Let's set the scene and take a look at the actual evidence we're going to be working with.
So, what we're looking at here is an incredible data set. This isn't made up, it's the real historical record from 1309 people who were on that ship, and most importantly for us, it tells us their gender and whether or not they survived.
Okay, so we've got the data. Now, how in the world do we find the hidden patterns inside of it? What tool can we possibly use?
Well, meet our detective's magnifying glass, the chi-square test of independence. Its whole job, its entire purpose, is to look at two different categories, in our case, gender and survival status, and figure out if they're connected or if they're totally independent of each other.
Now, this is the really clever part. The test starts with a super simple but crucial idea. It assumes there's no connection at all between the variables. It assumes gender and survival have nothing to do with each other. In statistics, we call this the null hypothesis, and our whole goal is to see if the data is strong enough to prove that assumption wrong.
So how does it actually do that? Well, at its core, it's this brilliant comparison between two things, what really happened and what we'd expect to happen if it was all just random chance.
Okay, first, let's look at reality. These are what we call the observed counts, the actual real numbers from the historical records. And right away, you can see something's going on, right? 339 women survived, but only 161 men. And look at this, 682 men died compared to just 127 women.
Okay, now for the cool part. The test does this really interesting calculation. It asks, all right, if gender had nothing to do with survival, what would these numbers look like? And you can see, in this random world, we'd expect 288 women to have died. But in reality, only 127 did. That's a huge difference.
And that, right there, is the whole point. The test just mathematically measures the size of the gap between what really happened, the observed numbers, and what pure chance would predict, the expected numbers. The bigger that gap is, the more likely it is that something real is going on.
All right, so we get the logic. It's reality versus random chance. Let's see what the final verdict from our detective is. What does the Titanic's data actually tell us?
So after the test crunches all those numbers, comparing the real ones to the expected ones, it spits out two key values. And these two numbers hold the answer to our big question.
Now the big one here, the one you really want to pay attention to, is the p-value. You can think of it like a coincidence meter. It tells you the probability of seeing a gap this big between reality and chance if it was all just a coincidence.
And our p-value, it's less than 0.001. That is tiny. It means there's less than a 1 in 1,000 chance that what we're seeing is just a random fluke. So we can confidently throw out that whole no connection idea. There is absolutely a real statistically significant relationship here.
Okay, so we know for sure there's a connection, but so what? What does that actually mean in human terms for the people on that ship? Let's break down the final takeaway.
To really get a feel for just how strong this connection is, we can calculate one more number from our data, and it's a really powerful one. It's called the odds ratio.
And this is where it really hits home. The connection wasn't just statistically significant, it was massive. The data shows us that male passengers were over 11 times more likely to die than female passengers. That whole women and children first idea, it wasn't just a saying, it was a brutal statistical reality.
So let's wrap this up. What did we learn? Well, the chi-square test is this awesome tool for finding hidden relationships between different categories. It works by comparing what we see in the real world to what we'd expect from pure chance. If you get a super small p-value, you know you found a real connection. And it lets you turn a plain old table of numbers into a really powerful real-world story.
And that kind of leaves us with one final thought, right? Now that you know how the statistical detective works, what are the hidden connections in the world around you? You know, things like customer preference and product design, or a new training program and employee performance. The questions are out there, and now you have a tool to go find the answers.